Yeah. Hi guys. Today we are going to discuss about some of the fabrication process of Nmos technology. Okay, now I'm going to discuss about Nmos fabrication process. Nmos fabrication process. Mostly we would like to discuss about at least 4 to 5 fabrication steps in this video. Okay. Now before going to discuss about the fabrication process, Nmos is classified mainly into two types. Okay, one is enhancement mode Nmos and another one is depletion mode Nmos. Okay, first of all, we are going to focus about Nmos enhancement mode. Later we will talk about the depletion mode Nmos. Now coming to the Nmos fabrication process. Nmos fabrication process. Okay, in the last video we had seen the fabrication steps. In the fabrication steps we are having first one wafer creation, the second step is oxidation, and the third step is photolithography. The third step is photolithography, and we had considered the fourth step as etching. Is it clear? I hope that up to these steps we will try to see the fabrication steps in this video. Okay, now coming to the first step, that is wafer creation. Wafer creation. Will you please tell me the another name of this? Yeah, okay, it is what? Substrate forming. We have to form a substrate. Is it clear? Now, this is the first step I would like to discuss in this. Okay, let us observe how the wafer is created. Let us assume that this is a silicon crystal. Okay, now it is something looking like this. Now, if you observe that from this silicon crystal, if you want to consider this substrate, okay, this one, if you want to consider this substrate, this one I am going to talk about this one. Is it clear? Let us assume that this is the substrate we have considered. This is the substrate we have to consider. And don't forget, this is a silicon substrate. Why? Because it is a silicon crystal. Now, the substrate, whatever you have considered, you should focus on the three parameters, or you can call three specification. The first specification you have to focus is diameter. Diameter, and the second one is thickness, and the third one is resistivity. Okay, now observe very carefully. The diameter should be 75 to 150 millimeter. Sorry for that. The diameter should be 75 to 150 millimeter. And the thickness is 0.4 millimeter. And the resistivity is 20 ohm centimeter to 25 ohm centimeter. These are the three specifications you have to focus, and after that remember very important point. Now which type of MOS transistor we would like to fabricate? Absolutely. What is that? NMOS. NMOS. Therefore, remember the substrate must be a p-type substrate. That means after creating a substrate, we have to dope some of the impurities of p-type in this substrate. Therefore, we should focus on the doping concentration. Is it clear? This is the fourth specification you have to remember. What is the fourth specification? Doping concentration. Doping concentration. Okay, what is the doping concentration means? Remember, it must be 10 power 15 to 10 power, sorry for that, 10 power 15 to 10 power 16, 10 power 15 to 10 power 16 per cubic centimeter. I hope that are you clear? Okay, now once again I will just recall the specifications. This is your substrate. Okay, for that the first one is, let it be diameter, which is 75 to 150 millimeter, and the second one is thickness, which will be 0.4 millimeter, and the third one is, if you observe that, resistivity, which will be 20 ohm centimeter to 25 ohm centimeter, and finally the fourth one is doping concentration 10 power 15 per cubic meter to 10 power 16 per cubic meter. Now don't forget students, after doping the necessary impurities of p-type, the substrate becomes like this. Is it understood? This is the first step. What is that? Wafer creation. Are you clear, all of you? Okay, now coming to the second step. After first step, our wafer is like this. This is our wafer. And coming to the step number two, what is the name of step number two? The name is what? Oxidation. I hope that are you clear. Now, after forming the substrate, you have to grow, okay, either oxygen onto the substrate or else expose with water. Now observe what happens if you expose with oxygen or else with water. Now I can call this type of step as dry oxidation and this type of step as wet oxidation. Now shall we see the chemical reactions of this? What happens? Is it clear? Now observe very carefully. Now if you grow an oxygen onto this is your substrate of p type. If you grow an oxygen, let us take some color for this. If you grow an oxygen, now observe very carefully. Previously the substrate is silicon. If you grow an oxygen, because of this chemical reaction, Sa plus O2 gives rise to what? SiO2, which will act as what? Insulator. Which will act as insulator. That means I can call this one is as SiO2. Okay, this type of oxidation is known as dry oxidation. Why? Because we are not considering any water content in that. I hope that are you clear. Now let us see one more step. Okay, second one, that is wet oxidation. In this silicon substrate, if you use water, H2O, here also you can form SiO2, silicon dioxide, but observe very carefully, you should balance the chemical reaction. Since here O2 2 is there, therefore you have to balance with 2. Then because you are having 2H2, therefore you should have one more extra. What is that? 4H. I hope that are you clear. Here, this is the step known as oxidation. After oxidation, what is the important thing you have to conclude? An insulator is formed. Is it clear? What is that insulator? Silicon dioxide. I hope that are you clear. Is it okay? Now, after the two steps, the first step is forming a substrate of p-type, and the second step is oxidation step. Okay, this is the step. What is this? SiO2. Is it clear? This is the thing, SiO2. Now coming to the important step we have to discuss. What is step number 3? Absolutely. What is that? Photolithography and its combination step. What is that? Etching. Absolutely. This is an important steps, especially you can call this one is the heart of the fabrication process. Why? Because these are the steps which will come repeatedly, okay, in the fabrication process. Okay, we will see this step very cleanly and detailedly. And observe, I'm going to start with the third step. What is the third step? Okay, photo lithography. I hope that are you clear, all of you? Okay, now observe this step. Now let us see, this is the substrate after oxidation we are having, right? Now we will take some other color to indicate SiO2. This is what our SiO2. This is SiO2. This is a P-type substrate. I hope that are you clear. Now observe very carefully. Before exposing to UV light, don't forget you should take a layer which is called as photoresist. Why? Because you have to protect from light, therefore you should before exposing your UV light, you should form a layer which is known as photoresist, which will protect from UV light. Okay, now observe what is happening here. I will take a red color for indicating light. This is a light I would like to expose here. This is my UV light. Okay, now observe very carefully. If you expose UV light directly onto the substrate here like this, the entire light falls on your photoresist. But this should not happen here in my fabrication process. What should be the aim of mine means, I would like to cover some area, I would like to allow UV light in some area. Therefore, for that purpose, I would like to use a mask which is known as photo mask. Therefore, I am going to use, here observe very carefully, I am going to use a photo mask. Is it clear? Let us assume that it is a photo mask. Okay, for this, see here how I am going to use. In this area, I am going to allow light. I will use some other color. In this area, I would like to allow light. In the remaining area, I would like to block the light. Is it clear? Now see here, by observing it, you can call, okay, this is the area, the shaded area where light is not going to be allowed. This is the area, empty area, where light is going to be allowed. Okay, by observing this itself, you can tell it is, okay, first of all, it is what? Photo mask. Photo mask. I will call this photo mask as positive photo mask. Positive photo mask. Why? Because by observing it itself, it is very clear to you guys. Okay, wherever wherever there is a shaded area, it will block that particular, okay, light. Wherever there is a transparent one, here this is a transparent one, it will allow the light. Now observe very carefully what will happen here. The light falls on where? The light falls on the photoresist. Okay, in the remaining areas the light won't be fall. Why? Because it is covered, it is protected, right? Now after that, what will happen? Observe very carefully yourself. Yeah, absolutely. What will happen? This area is going to be this one. I will use some other color to indicate this. Okay, this area, okay, sorry for that, I will go to some other color. This area, okay, is going to be depleted. Why? Because of the light. Sorry for that, because of the light, this area is going to be depleted. I hope that are you clear. Okay, now after that, what will happen? Observe very carefully. After this step, okay, photolithography, by using photo, that means by using light, okay, you are going to form a picture in this stone. In this stone, I hope that are you clear, of you? Okay, that is the name, carving a picture into the stone, onto the stone. Is it clear? Photo light, with the help of a light, you are going to form a picture of your choice, okay, into the stone. Is it clear? After this step, after photolithography, how the substrate look like means, observe very carefully. After photolithography, This is the substrate of U. Okay, don't forget it is a P type. And you are having a silicon dioxide. I will use some other color. Okay, this is a silicon dioxide. Okay. Okay, after that you are having a photoresist, but don't forget after, yeah, sorry for that. Okay, don't forget this is the area where UV light exposes, therefore the photoresist emitted. What is this? Absolutely, absolutely. What is this? Photoresist. Yeah, what is this? Yeah, very good. It is SiO2. That is a silicon dioxide. This is the step photolithography. After this step, I would like to continue with the fourth step. What is that step? Etching. Okay, in this step, in the yesterday's class, I said which acid we are going to use for this. Yeah, anybody? Absolutely. What is that? Hydrofluoric acid. Now observe very carefully. Okay, onto this one, onto this, I would like to expose a hydrofluoric acid like this. Okay, now observe very carefully. What will happen this? Absolutely, yeah, absolutely. If you observe that this area is going to be removed, I will use different color for that. Okay, to indicate. Yeah, this area will be removed here, and here photoresist will be removed because the hydrofluoric acid is going to be fall directly here onto the photoresist, but here it will fall directly onto the oxide, that means silicon dioxide. Is it clear, all of you? Now how this figure looks like after that, observe very carefully, guys. Okay, this is your, absolutely, what is this? P-type substrate. After this I will use different color for that. Yeah, absolutely. After that you are having like this. Yeah, absolutely, guys. Is it clear? This is what SiO2. Now if you observe that, sorry for that, if you observe that a window is opened here, a window is opened here in oxide, therefore this is known as opening a window, opening a window where in an oxide. I hope that are you clear, all of you. This is important steps. Okay, what are the steps we have seen? Wafer creation or substrate forming, oxidation. How many types of oxidations we have seen? Two types: dry oxidation, wet oxidation. And third one and fourth one is what? Photolithography. Don't forget, in the photolithography we have seen positive photomask. I would like to explain a negative photomask also. This is what? Etching. Is it clear? Etching. Okay, now coming to the photomask. This is the photomask we have used, where, okay, the shaded area blocks, UV light. What is the output of this? What is the output of this? Means here itself the light will come out. I hope that are you clear. This type of mask is known as positive photomask. Positive photomask. Okay. Now let us see here this one. Sorry for that. Let us see here this one. If this type of photo mask you are using, this is UV light. Okay, if this is UV light, if there is a shaded area like this, okay, if this shaded area allows UV light, okay, if the transparent area, this transparent area is going to be block UV light, this type of photomask is known as negative photomask. Negative photomask. Is it clear? Whatever the photomask you would like, you can use. I hope that are you clear, guys. Thank you very much. In the next video, we will see the remaining fabrication steps. Is it okay? Thank you very much. If you are having any queries, please comment. Thank you. Thank you very much. Have a nice day.